into um, how do we actually build and train a large language model, and then specifically a little bit of background about machine learning. Okay, some of you probably done machine learning courses before, some of you maybe first time, and we'll look at some of the very basic, okay, very simple, maybe hello world type of machine learning examples to understand how it works. Okay. All right, so very quick definition. Okay, so language model, this is how it works. Um, it does really complicated things, okay, very intelligent things. But really all it's trying to do, as we give the input prompt, getting all the responses, is that we send the input string or text, and then the model is trying to predict the most likely next word or sequence of words coming up. Okay, that's all where the model is trying to do. Once again, people talk about AI, people talk about intelligent stuff, AI agent, all of this. The fundamental thing we've been talking in the past 2, 3 years about AI is this little algorithm. Of course, we don't call it little algorithm, but it's this very, very advanced, very sophisticated algorithm that can take some kind of input parameter or input string and then generate a word or a sequence of words that's going to come next. But then all of this is based on the prediction. So there are some statistics involved. That's why if you look into more about some of the documentation, um, you can learn that a lot of the AI, the results is based on the statistics, probabilities. That's why in early days, if you look at the models, some models are not very good at math, okay, because it's really trying to predict the next words based on the probability. It's not trying to do the real calculation. But obviously, these days, the algorithms have been changed a lot. But the principle here we're talking about today, I think that's the most important, the most fundamental, um, uh, theory behind it. Okay, so basically, once again, to summarize, I gave you an input string or input sentence, and then you get the next word. Okay, so examples. So here I put a very simple sentences input. I leave blanks here, and you obviously don't need to know tell me the answer. If you read that first part, you can pretty much figure out what's the next word. Okay, um, very, very straightforward. So that process, as your brain is working to look at this input to figure out the next word, that process, that's exactly what all this large language model trying to do. Whether it's OpenAI's model, ChatGPT, Gemini model, DeepSeek model, any other model, they're basically trying to do the same thing. Okay, so this graph here give you a more straightforward demonstration. Okay, so that black box, that model we call large language model, it's really, really complicated. It takes a lot of effort to build. But once you have it, it just does this one thing, very simple thing, but it does it so well. Okay, you give very complicated things, and then it gave you really good, very accurate next words. All right, but how does it work? So, because if you think about when we use the ChatGPT, okay, you give an input, you give a sentence, you're not getting just one word. You're getting a lot of answers. It can give you essays, it can give you code. It's not just one word, right? However, you should understand that the even though you saw a large amount of output text, but the way it works is that it's giving you all these words one by one. Okay, so here example. So you have this Mary had a little. Okay. Now what the model is trying to do is to give you the next word. Remember, it's always the next one. You get the lamb, and then what they will do is attach that lamb back to that input, and you send that to the model again, and use that one to predict what's the next one. So you get one word, attach it to the back, and get the next one. Well, that's why when you're using any of these large models, when you get a response, it's always like a little bit typewriting type of animation. You never see the result come all at once. It's always comes word by word, line by line. Obviously, these days it's getting really, really fast. Okay, but you gotta understand that's not just an animation. That's basically how the model works, because every time the model give you just one word only, and you attach it back, you send it back again, you get the next word. That's how you see all the results. Okay. So whenever from now on as a CS major, you should realize that when you are using all the larger model and that very smart program behind it, it really does this one thing, very simple thing, but it does it so well. Okay. But in terms of how we're building it, obviously you guys already learned all of this or heard a lot of things, right? So it's really based on a training technique. The computer, when it's built, they have no knowledge about what to predict, right? So you gotta give them enough information to let a computer learn to see enough certain things so that the computer will know what to predict. And that way of working exactly how we think about things, okay? Because I was showing you all those blanks. The reason you guys can tell that is because at some point of your life, right, you have seen or heard those kind of sentences. And then very important, you're not just seeing it once, you see that multiple times. So you got this really good memory or impression about certain things whenever that shows up, and you know exactly what the next word is. So that process, okay, you see, you learn multiple times, you remember things, memorize things, and summarize some of the pattern. That process is exactly what the large model how it works. How do we build those? So in the same way, you basically supply a really large number of data, and then you're not just giving it once, you give it multiple times, and from different sources. And then we use the algorithm to like computer to structure this, to remember this, to connect them. So that way, eventually the model can predict things. Okay. So examples, assume that these are the training data. And we talk about Mary had a little, right? So in different articles, different stories, different sources, maybe the internet, the wiki pages, game stuff, anytime, we scrape out the data, we put them there. There could be multiple versions that starting with Mary had a little, okay? Um, but then how would the learning model predict it's a lamb? Well, it's not because that certain things are more famous, it's because you probably see certain things much more frequently. That's why I mentioned earlier, it's more about the probability. Okay, so you had all the different versions, but over the time, I saw one of them dominates the frequency. Okay, you see this more often. So in that case, more likely you're gonna get this type of output. Okay, so the results, it really depends on the data. That's why for any kind of this AI machine learning problems, the data is really the key. The data is the fuel. Okay. Especially these days, most algorithms are all open source. There's not too much secret. A lot of times the model works better because the data is better. Okay. So to build also language model, you just need the data, plus you train it, you use some algorithm to do it, and then you will get final results. Okay, this one would go a little bit more technical, right? So you got all of this input text. Okay, so what are we gonna do next? Since I mentioned that you gotta teach the computers how do you predict the next word, right? So what you want to do is that you want to basically restructure all the text to really split the input and output. In this case, the input will be the first part of the sentence, and then output will be all this keyword. So this will be a more a better way to see how the input data will be used for the training process. So for all the sentences, okay, so if you decide you're gonna predict this key like nouns after the first part of the sentence, you gotta break down all the sentences and put them into an input and also output structure and throw them into the table. That's how you can correlate the two of them. And then you gave all of this to a specific algorithm, data, and then that algorithm will be able to pick up relationship. They will be able to predict one thing from the other. Okay. So to summarize, okay, so we talk about this large language model. We're trying to predict the next word from the input. The way it works is that you supply a lot of attacks, you structure them, split them, and get the most important information. You give it to this machine learning model and let it run. That could take a lot of time and resources. That's why you use all this NVIDIA graphics card to do this when you have a large amount of data. But once it's done, you will get this very intelligent and powerful model. Okay. So this part here is obviously it's a very simplified version of how the large language model works, but the big steps are the same. Okay. You do need the data, you need the algorithm, you need the machines to, um, to put everything together. Okay. You can't do this without any one of this. Okay. Uh, so recently, the NVIDIA, the stock is really good because every company, whoever want to train the data, they need a really good graphics card, they need chips. So that machine part is important. However, why OpenAI's model is better? Because they have smarter algorithms. So their training approach is more advanced. So just having chips doesn't mean anything. You got to have the right programs. That's why software always plays a very important role in this kind of situation. Another thing you can't really neglect is that the data part. Okay. So that's why Google often has a pretty good advantage in this field, even though Google was a little bit late behind OpenAI, but they're never going to be an issue because they actually probably have a better access, better control in terms of data, in terms of the information they can access. Okay, so that's also the important part. Okay. Yeah. So once again, as a CS major, from now on, you gotta, know as you're interacting with all this prompt, with the models, with learning models, behind the scene, this program trying to get all these words, gave it to you one by one, attach it back, keep doing this one. And then before we use that model, before they launch the model, a lot of engineers, they put together this very sophisticated program to let it go, run for a while, and once you get a model, and then everyone start to use. Okay, so that's the whole picture. Okay. All right. So any questions? Yeah. Now, if you remember, I mentioned that the first couple weeks, our goal is not is for you to understand not only how the model works, but also potentially let you guys to build your own very simple, tiny hello world model, your language model, how it works, right? In order to do that, well, you do need to understand how the machine learning works. How many of you have took machine learning courses already? Okay, very good. Is that from our department or is the online course you did somewhere? Or CS course, right? Yeah, very good. So I think we do offer different kind of version of machine learning course. If you got a chance, definitely take it, okay? Because that way you will dive into more about machine learning, all the different algorithms, and maybe they will also touch about the some of the series, the algorithms, deeper, maybe from the mathematical point of view. But in this case, we're not going to talk too much. I'll just give you the simplest example and to let you to understand how it works, especially how you do that through programming, okay? Again, just a quick overview is about